most welcome. My name is Mush. As usual, we always begin with correction or answers for the last activity. They left you with the two numbers, of which we're going to begin those ones. And I've made correction here. You remember we said mechanical advantage for a single movable pool is 2. And we got this one here just because of the number of times this rope is supporting. The number of times the rope is supporting this pulley. You see, this one here is going to be effort 1. This one is going to be effort 2. 1, 2. So that is why we are getting our formula of mechanical advantage being 2. Because of this number of times the string is supporting the what? The pulley. And you discover that according to the last time's work, when we were looking at pulleys, levers, you discover that the program is always between the load and the effort, and that one calls to be first class lever. And you discover that pulleys that are single fixed have taken the position of first class levers, and pulleys that are in that are movable take the second class lever. We take this one here to be the first, then this one here to be the second, and then you find that this one called first to be in second class lever. As you were watching, we have said we want to make this correction, and we have said I went here just to make you know where we got 2 as mechanical advantage. We have said the number of times the rope are supported at the moving pulley. Yep, we say we had got 60 as the weight or the load, and we wanted to look for effort that was used to raise 60 kilograms. We have said mechanical advantage is equal to load out of effort. Mechanical advantage is equal to load out of effort, of which effort has not been given, but we have been given 60 kilograms as our load. We shall therefore say, having discovered mechanical advantage of a single movable pulley is 2, we shall say 2 is equal to 60 kilograms out of E, which we are looking for. And therefore we shall get the answer through multiplication. We shall multiply, cross multiplication. We shall get 2 out of 1, 6 out of E, then cross multiply by 1 to get 2 times E, we shall get 2E, and 1 times 60, we shall get 60 kilograms. And when we divide 2 by 2, you get 1 here, and then we get 6 divided by 2. By 2 here we're going to get 1, and by 2 here we're going to get 30, meaning E is equal to 30 kilograms. But I have said we look for effort. We shall say therefore effort is equal to 30 kilograms. That is activity 1. Activity 2, we get the same formula. We have said mechanical advantage is equal to 2, and our load has been given as 80, and effort is not known. We should look for effort. Following the same method, we shall say mechanical advantage is equal to load out of effort, of which our mechanical advantage here is 2, following the number of times the rope or the string or the chain is supporting the pulley. We get 2 is equal to 80 out of E. We shall cross multiply, and here we shall use 1 such that we get the weight. I shall say 2E is equal to 80, of which we are to divide each side by 2 to get E isolated. Shall we say E is equal to 40? And I've said, remember the question was what weight, what force would be required to raise a load of 80 kilograms. Shall say 40 kilograms is required to raise a load of 80 kilograms. That is correction for activity that we are given the previous time when we are with you here on the camera. For today, I want us to move quickly through this. After making correction, I'm sure you have finished. Alright? Today we want to look at block and tackle. Pulleys. Block and tackle. We are still on pulleys. After seeing single fixed, we also looked at single movable, and today we're looking at block and tackle, the one we can call multiple pulleys, the one we can call fixed movable pulleys. And in these pulleys here, the number of times, what the mechanical advantage depends on the number of times the string, the number of strings, the parts of string that have helped in supporting in the lifting of the load. That one makes us come to the to the mechanical advantage. Let us say block and tackle. Block and tackle pulleys. Can also call them fixed movable pulleys. And what is a block and tackle pulley? We have said a block and tackle pulley, it is a combination of several fixed and movable pulleys. Block and tackle, it is a combination of fixed and movable pulleys. When you get fixed pulleys combined with movable pulleys, shall come out with what we call block and tackle pulley. Like we said, these pulleys have got the number of advantages, and I've also got, like we said, what makes them come to the number of mechanical advantage. We shall look at, it depends on the mechanical advantage required. For example, if you want your work to be done faster, you shall increase the number of pulleys, and that one will determine the mechanical advantage. Before any other item, let us look at advantages of block and tackle. Pulleys or pulley. Block and tackle pulley. One, we said that this pulley or pulleys change direction of force. Change the direction of force. Two, reduce the effort required. Three, work is done faster. You should always identify advantages of single movable pulleys, advantages of single fixed pulleys, And here we also see advantages of block and tackle, call them fixed movable pulleys. We have said 1, change the direction of force, 2, reduce the effort required, and 3, work is done faster. Okay, let us have an illustration here. An illustration. There are very many modes of block and tackle pulleys. Like we have said, it depends on the number or the mechanical advantage required. So let us use this one here. Let us use this one here. Remember I said that block and tackle pulleys are made up of single fixed and single movable. And when you look at single fixed pulleys, you find that the pulley has been fixed and it is the rope that moves. And when you come to single movable, it is the pulley that moves, whereas the rope has been fixed on the block. Now, like we have said, in block and tackle, the mechanical advantage depends on the number of parts, a string or a rope or a chain that supports the moving block. Shall say, for example, this one here is 1, this one here 3, 2, this one here 4. So you can say effort 1, effort 2, and effort 3. Effort 3. And here you can have our load. Maybe as 200 newtons. So if you are to be asked to find the mechanical advantage or to look for effort, which force was used in doing work using this form of a pulley, you need to look at the number of strings or parts of a string that have been used in lifting the load. Like we said, this is part 1, the one we are calling effort 1, part 2, and therefore our mechanical advantage, we can say, let's find the mechanical advantage. Let's say, let's have here 150 newtons. 150 newtons. This is an example, an illustration of block and tackle. Good. Let us have calculation on block and tackle here. Block and tackle. If we were to look for mechanical, effort here, and we discover that if we want to discover the mechanical advantage, use the number of parts of the string that it has been able to support the moving load. And you see that this 1, 2, 3, meaning here our mechanical advantage is going to be 3. But always say, and our load there is 150 kilograms, and our effort is not known, and therefore we should look for effort. But the mechanical advantage is equal to load out of effort. But according to the pulley, the one you are seeing, block and tackle, we have said there are 3 parts on this rope that are helping to move this load here, of which our parts are going to be 3. Remember, I've said mechanical load is 3. I said 3 is equal to load, which is 150 kilograms out of E. We're looking for effort. Here we shall come to cross multiplication. We shall have 3E is equal to 150 newtons. We have used newtons. Sorry, I've used newtons. Okay. Divided by 3. Divided by 3. 3 by 3, 1. By 3, 1. By 350. Therefore, our E here is 50 newtons, and therefore shall say, therefore effort needed is 50 newtons. Now that one stands as our answer. And remember, we should always use the units we have been given, and here we are supposed to use newtons. Don't change, because you're always used to kilograms and you put everywhere kilograms. So if you have been given on load kilograms, should always use kilograms. Don't change. If you have been given newtons, apply newtons. So we come out and get that our effort here is 50 newtons. This is the effort needed to lift the load of 150 newtons. I'm sure we can discuss more, and you have some other books at home. You can use those books and you discover more examples and you calculate more. For now, I want to leave you with this question here. Activity 1. Find the effort needed to lift the load of 200 kilograms, to lift the load of 200 kilograms using the pulley below. And I would wish you to find more examples of single fixed, single movable, and block and tackle pulleys. And then you keep on trying those numbers such that the time we meet, you would have reached somewhere. I encourage you to follow your parents' requests, be good children, such that when we meet, we find you and you're still okay. May God bless you and continue watching.